Today I will discuss the oscillator. The next topic is oscillator, and I will discuss oscillator. So first, what is oscillator? So I think all of you know the oscillation. Oscillation means your output is not stable. Your output is not stable. You are across the output side. You are getting the across the output side. You are getting the oscillation. Means across the output side, you are getting any type of waveform like this. Okay, like this, or any type of waveform, and it is not constant. It is continuously changing. Okay, with the time changing. So these are the oscillations. Maybe sawtooth waveform. These are the oscillatory waveform. Okay. So in case of oscillators, across the output, you are getting the oscillatory waveform. You are getting the oscillation. You are not getting the stable output. Is it okay? Now, oscillators are what? Oscillators are such type of device which gives you the oscillatory output. So the device that generates different type of waveform with different amplitude and different frequency. So whatever the frequency and amplitude of this waveform, so suppose here this is the baseline, this is the PM, or this is the peak to peak amplitude. So this is the amplitude. So you hear the in case of oscillator, you are getting the waveform with different amplitude, and the amplitude may be varied, okay, and different frequency. Frequency is also varying. This is the time axis, and this is the amplitude axis, okay. And you know time is equal to 1 by f, means time period equal to 1 by f, means time is depend on the frequency, okay. So in case of oscillator, device that generate different types of waveform with different amplitude and different frequency is called the oscillator. Now, the type of waveform, what type of waveform you are getting across the output side, the type of waveform generated by the oscillator depends on the components. Whatever the components are using in the oscillator, this component by use different components generate the different type of waveform. So by the oscillator depends on the type of waveform generated by the oscillator depend on the component used in the circuit. So whatever the oscillator waveform you are getting, so what type of components you are using, it is depend on that. And hence it may be sinusoidal. Your waveform may be the sinusoidal. It may be the square or triangular or rectangular, any type of waveform or sawtooth you are getting across the output side of the oscillator. The frequency of the oscillation is determined by the component in the feedback circuit. So, in case of oscillator circuit, one portion is for the amplification and other portion for the feedback. And whatever the component used in the feedback circuit, that component control the frequency, and whatever the component used in the amplification circuit, that component that component control the amplitude portion. Okay, that this will I will discuss. So I think what is oscillator? It is clear. You are getting the by using the oscillator, you are getting the different types of waveform across the output side. Okay. Now, if you remember previously, I was discussed the feedback network, feedback amplifier. So in case of feedback amplifier, if you remember, uh, this is the input voltage. Suppose signal voltage Vs. There is the amplifier with gain A, amplifying circuit. Amplifier is with gain A. there is the output V0. There is a feedback network having the uh, feedback ratio beta, and this is back to the input side. I think all of you remember know this circuit. This Vs is this is always positive. Your feedback is either positive or negative. Okay, this signal is Vi. Vi is the input going to the amplifier. Vf is the feedback voltage. V0 is the output voltage, and Vs is the signal voltage. So this topic I already discussed in the feedback amplifier. Uh, Here your Vf is feedback voltage, and it is equal to beta times V0. Means some portion of output voltage is back to the input side. So how much voltage is back to the input side? So beta times beta part of V0 is back to the input. So Vf is equal to beta V0. This beta is basically the feedback. This is beta is basically the resistive circuit. There is a resistance in this circuit. So this portion we already discussed in the feedback amplifier. Now next, Wien Bridge Oscillator. So next topic, this oscillator. Okay, before that, one topic is there. For any oscillator, there are two criteria for the oscillation, and these two criteria is called Barkhausen criteria for oscillation. Barkhausen criteria of oscillation. So for any oscillation, these two criteria must be fulfilled. The first criteria is what? The loop gain is equal to the unity, that is mod of A beta equal to 1. So loop gain equal to unity. This is the first criteria, Barkhausen criteria. That means your mod of A beta equal to 1. Means the product of this amplifier, gain of amplifier, and this beta, so mod of A beta equal to 1. This is the first criteria. And second is your output voltage and your input voltage. The phase difference between the output and input voltage is defined here in the second criteria. So first criteria is A beta equal to 1, mod of A beta equal to 1, and second criteria is the phase shift uh, around the loop is 0. Phase shift around the loop is 0, or is 0, or integral multiple of 2 pi. So the your input signal and output signal, this V0 and Vi, V0 and Vs, input and output signal, phase shift is 0, either 0 or integral multiple of 2 pi, means n 2 pi, where n equal to 1, 2, 3, 4, like this. So these two criteria should be uh, fulfilled for the oscillator. Okay, oscillation. And these two criteria is called Barkhausen criteria for oscillation. Next, these oscillators are a different in number of types, but in your syllabus, two oscillators are included. First is the Wien Bridge oscillator, and other is the phase shift oscillator. So today I will discuss this Wien Bridge oscillator. Okay. Up to this, any query, question? यहाँ तक किसी को कुछ पूछना है? Yes, no. कुछ पूछना है तो बोलो. Up to this, any query? Can I continue?
Yes, sir, no problem.
So, what is oscillator and criteria for oscillation, Barkhausen criteria? These two topics we have discussed so far. Next, one type of oscillator is Wien Bridge oscillator. So, this is the circuit for Wien Bridge oscillator. So, in this circuit, you can see there is the open. There is R1 resistance, the negative terminal. RF is the feedback path, and there is also a positive feedback path is there. This Vf is the feedback voltage. Vf is back to the input, so Vf is the feedback voltage here. V out is the output voltage of the circuit. देखो सर्किट याद करने का तरीका है कि उसको हाथ से ड्रॉ करो, एक बार दो बार ड्रॉ करोगे वो याद हो जाएगा, ठीक है, उसको हाथ से ड्रॉ करना होगा, सिर्फ देख के नहीं याद होता. So in this circuit, Vf is the feedback voltage. You can say V0 is the output. So Vf part is back to the input side. So Vf is the feedback voltage. In this feedback part, this is the feedback network. Here, one resistance is in series with the capacitor, and other resistance is parallel with the capacitor. So this part is feedback network, and this part is used as amplifier circuit. So your amplification means your amplitude. This is the amplitude axis for the waveform. This is the amplitude axis, and this is the time axis. Okay, time is related to frequency. T equal to 1 by S. Okay, so this is the amplitude axis, and this is the, you can say, time axis. This type of waveform or any type of waveform is there. So this amplitude is controlled by, or amplitude is changed by this circuit, amplifier circuit. Okay, and the frequency portion is changed by, frequency of the waveform is changed by this part, feedback network. Okay, so frequency is controlled by feedback network, and amplitude is controlled by amplifier circuit. Next is, so this is the all about the Wien Bridge Oscillator circuit. Just to draw this circuit, देख के दो बार draw करोगे याद हो जाएगा, बहुत easy circuit. There is the op-amp, negative terminal, positive terminal, inverting terminal, non-inverting terminal. Your feedback is voltage is connected with the non-inverting terminal. Inverting terminal, there is a resistance, and RF is the feedback resistance connected between the output and inverting terminal. Next is second circuit. This circuit is what? Equivalent circuit in the bridge form. So this B number circuit, this circuit is same as circuit A. This circuit is converted into bridge form. You know the bridge form? Bridge form is, this type of form is called bridge form. So your circuit, this circuit is converted into bridge form. Same circuit is this. So how it is shaped, I will discuss here. You can say this is the feedback voltage, this is the output voltage, this is the ground, this is the ground, okay, ground, and this is the voltage. Sorry, this is the point between the R1 and RS. Suppose it is the A. Suppose you can see in this diagram. You can see in the diagram. This is VF. So this is your VF. VF is connected to positive terminal. Your VF is connected to positive terminal of the op-amp. This VF is connected with this R and C parallel path. So VF is connected with R and C parallel path. VF is connected with this RC series circuit. So it is connected with RC series circuit. RC series circuit, other terminal is across the output. So here it is. This is the output terminal. Next, this part you can see here. This R and C, this terminal is grounded. So here it is. This terminal is connected to grounded. Then your R1 is there. One terminal is grounded. Your R1 or one terminal is grounded here. This point, suppose A is between the R1 and RF. So this is your A point is, suppose it is between the Rn and RF. So this same circuit, this circuit and this circuit is same circuit. Just this circuit is it is in the bridge form. Okay. देखो इसको compare करो. This circuit is same. कुछ change नहीं है. एक ही है दोनों. Is it clear? देख लो, compare कर लो. Both circuit is same circuit. This is output voltage. Here, this is output. Up to this, okay? Take लो, समझ लो. If any issue, then you can ask. Can I continue?
Yes, sir.
Next is the feedback circuit and feedback circuit of first 3-number circuit. So देखो, this circuit is feedback circuit, means whatever the feedback network, this portion, ये जो portion है feedback network, इसको इस portion के लिए एक अलग सर्किट बनाया गया है. Just this portion. ये portion देखो कैसे, VF is the feedback voltage and this terminal is the your what connected to output. So this is the V0, the output. Okay. So same this circuit अलग से इसको बनाया गया है. So here VF, this point is VF and this is the V0 point. VF से क्या है, R and C दो पैरेलल में है. फिर VF से क्या है, R और C जो है आउटपुट और VF के बीच में सीरीज में है. Okay, so this circuit is the feedback circuit of this portion. Same circuit. Is it okay? This is the feedback portion of the Wien Bridge oscillator. समझ में आया? This terminal is VF terminal, feedback voltage. This is the output terminal of the oscillator. R and C one parallel and R and C one series. Same circuit, just we take the feedback network separately here. Clear it is? Yes, no? Here, R is parallel with C, R is series with C, and output voltage. ठीक है? Simple. अभी तक कुछ नया नहीं है, वहीं से कनेक्टेड है. Clear it is?
Yes, sir.
नेक्स्ट देखो, ऊपर में क्या था, VF यूज था, यहाँ पे VF ऑफ है. तो ऊपर में देखो फीडबैक वोल्टेज एंड आउटपुट वोल्टेज V out और V0, V out और V0. Okay. So this voltage VF and V out, it is in the time domain. Time domain. And here VF of S, it is in the frequency domain. And here V out of S, it is in the frequency domain. Out of S. So S is called the, T is the time domain and S is the called the frequency domain. Frequency domain. So here in this circuit is same, but the all components are converted into frequency domain. All of you know the Laplace? Anyone? Laplace transform? You know? Yes, no? अरे मैथ में है, कितने साल से तुम कर रहे हो ना, मेरे से ज्यादा जानते हो Laplace. Yes, no? है ना? Everyone know the Laplace? Laplace किया हो ना पहले? बहुत ज्यादा Laplace नहीं जानना है, मेरे लिए थोड़ा सा जानना है, और जितना मेरे लिए जानना है उतना मैं बता दूंगा. So you just know the term Laplace? Yes, no?
Yes, sir.
So everyone know the Laplace or Laplace transform. This Laplace or Laplace transform LT. All of you know this. सम तो पता है कम से कम, कितना सॉल्व करने जाता है वो सेपरेट है. अब देखो ये क्या कह रहा था मैं, हाँ, गेम क्या है, लैपलेस तुम लोगों ने बहुत किया है. व्हाट इज द यूज ऑफ दिस लैपलेस? लैपलेस का यूज क्या है? इफ इन केस ऑफ इलेक्ट्रिकल सर्किट, if the for the reduce the complexity of calculation, we transform the equation from time domain to frequency domain, as it's called the frequency domain. Okay. So for changing the time domain equations into frequency domain, we need the Laplace transform. So here your time domain signal is converted into frequency domain. So in time domain, it is Vf or Vf of t. It is denoted by Vf or Vf of t. And in frequency domain, it is denoted by Vf of s. Then your V out is either V out or V out of t in time domain. And in frequency domain, it is V0s or V out of s. So this is in the frequency domain. Okay. So just representation क्या होगा? V f of s and V out of s. Okay. अब changes क्या है? In case of component, suppose like resistor. So in case of time domain, resistor is R, and in case of frequency domain, the resistor is R. Same it is. In case of time domain, capacitor is C. In case of time domain, capacitor is C. And in case of frequency domain, it is 1 by Cs. So your capacitor is 1 by Cs. If there is some inductor, so in case of time domain, if the inductor is L, so in case of frequency domain, it is Ls. बस ये थोड़ा सा चेंजेस है जो मेरे काम का है, इससे ज्यादा लैपलॉस मेरे पास नहीं लगेगा. It is okay, everyone. R is same in volt domain. Capacitor C is replaced by 1 by Cs for the frequency, and inductor is replacing Ls. Ls भी यूज नहीं होगा, जस्ट C से ही काम हो जाएगा हम लोग. Is it clear, everyone? So your R is replaced with R, C is replaced by 1 by Cs because we draw the circuit in the frequency domain. Then here R is R and C is 1 by Cs. So this circuit is in the frequency domain. Same circuit it is in the frequency domain. Okay. Yes, no, up to this. ये आगे जाओ. नेक्स्ट बोलबो. Yes, no.
हाँ सर.
So up to this circuit clear it is. Next is देखो. This is the equivalent of this feedback. Simply this R is parallel with Cs. So this whole part is this R is parallel with Cs. So here this Z1S is the R parallel Cs. इसको जो parallel circuit है उसको single form में लिखा हुआ Z1S, where Z1S is the R parallel Cs. Then here R is series with 1 by Cs, or R is series with this capacitor. So your Z2S is, this is the Z2S. Z2S is R plus 1 by Cs. Okay. This is the same. So this is the equivalent circuit of the feedback network, same circuit. Next is, we know in case of feedback amplifier, your feedback voltage Vs equal to what? Beta times V0, where beta is the feedback ratio, V0 is the output. So by using same thing, here the V out is equal to, Vf equal to beta V out, or beta equal to Vf by V out. From this equation, you can write beta equal to Vf, means feedback voltage, by output voltage. Next, what is Z1S? Z1S is the R parallel 1 by Cs, and Z2S is the Z2S. Z2S is equal to R series with 1 by Cs. So R series was with 1 by Cs is R plus 1 by Cs. We are getting this equation. And Z1S R parallel with 1 by Cs. So R parallel, suppose R1 parallel R2. To know what is equal to this, so it is R1 into R2 divided by R1 plus R2. So here your R2 is 1 by Cs. If you solve it, you will get R by 1 plus SCR. This equation and this equation. Z1S and Z2. Up to this, any okay it is. Just Z1S is what? R is parallel with 1 by Cs. Z2S, R is series with 1 by Cs. To solve it. Next, from this circuit you can see, from this circuit, suppose V out is the output voltage, and here in this loop, the current flow is I1S, IS. Here the current in this circuit is suppose पॉजिटिव से निकल के नेगेटिव में जाएगा, तो here this is the current direction IS. So IS is current flowing in this loop. So if you use this, then you can see VFS equal to what? So VFS equal to this voltage equal to what? This impedance into current flowing through this. So VFS equal to impedance is Z1S, and here the current flowing is IS. So Z1S into IS is the equal to VFS. So VF of S equal to Z1S is this impedance, and current flowing is IS. So Z1S into IS. This is the one equation. Next say V out as, if you apply the KVL in this loop, so V out as equal to what? All impedance into current flow. So V out as equal to Z1S and Z2S. If you see in this circuit, so this is in series Z1S and Z2S. So V out equal to Z1S plus Z2S into IS. This whole into IS. This is equal to V out. Same, we know beta equal to VF by V out. So here we find out VF by V out in S domain, VFS by V out. So this equation and this equation, VFS by V out, we divide these two, IS and IS is cancel out. So you are getting Z1S divided by Z1S plus Z2S. This one. Yes. Next, you put the Z1S and Z2S. Here we are getting Z1S and Z2S. You put this in this equation. You are getting some simplified version. So just put the Z1S. It is R by 1 plus SCR. Z1S R by 1 plus SCR, and Z2S is 1 plus SCR divided by S. You put it, you are getting this expression. This solve, you are getting SRC divided by this function. Next is divide numerator and denominator by 1 by SC. 1 by SC is numerator and denominator both is divided. You are getting this expression. So R divided by 1 by SC plus 3R plus SC R square. Okay, so this expression, just simple mathematics. All of you go through this and find out this. So you will find this. So here VFS by V out equal to you are getting this expression. Next, in case of frequency domain, your S equal to S is the frequency domain. Here in S, this S is equal to Z omega, where this J is the complex number, J equal to under root minus 1, and omega is the angular frequency. So substituting S equal to J omega in this equation, you will get here beta means what? VFS by V out S is your beta divided by, and this is equal to R. Must just put J omega in place of S. So same equation here, R, just put S equal to J omega. So here 3R. This portion is S, so there is J omega, then CR square. So here CR square is there. 1 by SC, just put J omega in place of S. You are getting this equation. So just simplify this, you are getting Here 1 by j term is there. So if 1 by j term is anywhere, तो j को क्या होगा ऊपर में ले आना. In that case, you divide j by j in numerator and denominator. Then you are getting here j divided by j square, and j square equal to what? J square equal to minus 1. So that means it is minus j. So by using this concept, here this 1 by j ऊपर में j चला आएगा, and there is a minus, so minus is there. Okay. If you get the j in denominator, just multiply j by j in numerator and denominator. तो नीचे में j square हो जाएगा, j square equal to minus 1. So put minus 1 and j ऊपर में रह जाएगा, ऊपर में चला आएगा. So here this is the minus j. Okay. Now next j is, जब j ऊपर में आ गया, j will be common here. j को common में ले लिया. So here it is r divided by 3r plus j is common. You are getting r the omega r square c minus 1 by omega c. This portion you are getting. Okay. So beta you are getting r by 3r plus j omega r square c minus 1 by omega c. So this you are getting. Next is this beta is a real quantity. Beta is a real quantity. So beta is real means this j is a complex quantity. J equal to under root minus 1. That means it is a complex quantity. So if this beta is real, then whatever the complex values are there in the expression or equation, this complex value is equal to 0 for making the beta real. So for beta is real, this j का जो भी j के साथ में this value will be 0. So hence this omega r square c minus 1 by omega c, this is equal to 0 since the beta value is real. So if this part is 0, then from this part, अब इसको इधर में ले आओ right side में, तो 1 by omega c इधर चला आया. So from this you are getting omega equal to 1 by rc. This you are getting from this equation. Omega equal to 2 pi f. Okay. Omega is the angular frequency and f is the frequency of oscillation. So from putting omega equal to 2 pi f, so 2 pi f equal to 1 by rc. So from this you are getting f equal to 1 by 2 pi rc. So this is the frequency of oscillation of your output waveform. Frequency of oscillation of the output waveform. Clear? बहुत ज़्यादा टफ नहीं है. Just from the feedback network, we will find the Z1S, Z2S, easy. Then we use the VF equal to beta V0 this equation. So VF by V out करेंगे. You are getting the equation for VF by V out, that is beta, and putting the S equal to j omega in the equation, you will get the beta, and whatever the complex part in the beta, that will be 0 for making the beta real, and from that you are getting frequency of oscillation f equal to 1 by 2 pi r. Next is the frequency of oscillation is f equal to 1 by 2 pi rc we are getting. So if in this now in this equation you can see beta equal to r by 3r plus j something. So this part is complex part is 0. So your beta equal to what? Beta equal to r by 3r. So we put beta equal to r by 3r here. So r cancel out. We are getting beta equal to 1 by 3. So here we are getting the beta equal to 1 by 3. Next, we know for a oscillation from the Barkhausen criteria, your A beta equal to 1. So from this, your A equal to 1 by beta, A equal to 1 by beta, beta equal to 1 by 3. So here A is equal to 3. So you are getting the amplification P. Now you can see in the circuit here, your this negative terminal is connected to ground. This negative terminal is connected to ground. That means this is a circuit for your signal voltage is in the positive terminal. Yes, feedback voltage is the signal voltage. So your signal voltage is in the देखो कहीं पे होगा मुझे याद नहीं. So your signal voltage is applied in the positive terminal and negative terminal is grounded. तो ये कौन सा एम्पलीफायर है? Your signal voltage in the positive terminal and negative terminal is grounded. Which type of amplifier it is? Inverting amplifier, non-inverting amplifier, कौन सा amplifier? Anyone? Signal voltage positive terminal में है, means non-inverting terminal में है, so it is the non-inverting amplifier. If the signal voltage is in inverting terminal, it will be inverting amplifier. So for the non-inverting amplifier, the gain is what? We already seen in the op-amp classes. For the non-inverting amplifier, your V0 equal to 1 plus RF by Rin or input resistor into V. This is we are discussed in the op-amp class. And for inverting amplifier, V0 equal to minus RF by Rin into V. So here it is non-inverting amplifier. So your V0 equal to 1 plus RF by Rin. Rin is the input resistance into V. So from this, here in this equation, this 1 plus RF by Rin is the gain. So here 1 plus, here in this circuit, your gain is 1 plus RF by R1. Here Rin is, we taken the R1 in the circuit. So 1 plus RF by R1 equal to 3 here. Gain is 3, A value is 3. So 1 plus RF by R1 is 3. We put here. Then by simplifying this equation, we are getting RF equal to 2R1. So your feedback resistance is equal to 2R1. You are getting this. Now this is equation 2, and previously this frequency of oscillation, this equation is 1. So this, if this two equation is satisfied in the circuit, in that case you are getting the sustained oscillation, means you are getting the continuous oscillation across the output side. Okay. So this is the here you are getting what is the criteria of oscillation for Wien Bridge oscillator. So this is the two criteria here: frequency equal to 1 by 2 pi RC and RF equal to 2R1. If these two conditions is satisfied, then you are getting the oscillation in the Wien Bridge oscillator. So this is all about the Wien Bridge oscillator. Next, there is some explanation of this Wien Bridge oscillator is there. So just go through this. It is commonly used oscillator in audio and sub-audio frequency. Whatever the frequencies you are getting, it is in the audio range and sub-audio range. And range is 20 hertz to 20 kilohertz frequency you are getting across this oscillator. It is simple to design. The design is simple and compact and provides good frequency stability. Where the frequencies are not very much fluctuating, you are getting the stable frequency. The output waveform is relatively free from distortion, means there is very less noise across the output, and its frequency can be varied easily. Means you can vary the frequency easily by changing the input side parameters like R or C. The maximum frequency output of a typical Wien Bridge oscillator is limited to about 1 megahertz. So maximum frequency is in the range of 1 megahertz. Figure A means first figure shown the Wien Bridge oscillator which have a lead lag RC network. Lead lag RC network introduced in between the amplifier input and output. So in case of input and output, there is a RC lead lag network is there. The bridge has a RC network in series connection and a parallel RC network in adjacent. Whatever the connection diagram, one RC is in series and other R and C is in parallel. These things are explained here. So by introducing Wien Bridge oscillator feedback network, the oscillator becomes sensitive to a signal of only one particular frequency. This particular frequency is that at which Wien Bridge oscillator is balanced. When the oscillator is balanced, then you are getting the oscillation, sustained oscillation, and for which the phase shift is zero. This is the basic criteria of oscillation. Phase shift is zero or integral multiple of 2 pi. Okay. This topic is over. Any query at any point? कहीं समझ में नहीं आया किसी पॉइंट पे तो बोलो, मैं डिस्कस कर दूंगा फिर. Oscillator से simply design the oscillator. You have to draw the circuit and find out the criteria for its condition for oscillation here. So this derivation is also you have to derive in the question. So this question you are getting here. Okay, circuit diagram and condition for sustained oscillation. So this equation 1 and equation 2 you will find out for the condition for sustained oscillation. Clear it is? Yes, no? क्या बात है, नींद आ गई क्या सबको?
नहीं सर.
कितना समझ में आया? आया नहीं आया?
आया सर.
ठीक है, मैं इसको शेयर कर दे रहा हूँ और इसको देखो. टफ नहीं है. देखो एनालॉग से जो भी टॉपिक है ना उसमें क्वेश्चन स्ट्रेट फॉरवर्ड है कि यही क्वेश्चन है, उसमें बहुत ज्यादा घुमाने लायक नहीं है. थोड़ा अगर डिफिकल्ट भी हो तो अगर क्वेश्चन पहले से पता हो कि यही चीज आना है तो इजी होता है. ऑल ऑफ यू गो थ्रू दिस. आई विल शेयर द नोट्स विथ यू. जस्ट go through that. If you face any issue then you can